Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of inequalities, specifically how we can create inequalities and combine like terms, and we'll do it in 5 minutes or less. So we have a sample problem here and a whole bunch of clues. So Carlos is collecting Pokemon cards, and you notice we have an unknown in that very first clue. He collected X cards during January. So what I'm going to do is I'm just going to kind of write a little calendar here. And I'm just going to say, all right, so we have X unknown cards in January. He collected 5 less cards in February than in January. All right, so in my little calendar that I'm creating here, or it's going to end up looking like a table, right? What we have here is January is X. February is 5 less than that. We don't know what X is, but that's fine. We can still represent X. Then we can say minus 5. Let's take a look at the sentence clue here. He collected 5 less in February than January, and we can kind of replace that January with X. So 5 less than X, or X minus 5. All right, so we have that. And then he collected 3 times as many cards in March as in January. So everything goes back to January, and January is unknown. January is this X. But they do give us something here. 3 times as many cards in March as in January. So what I'm going to do here is I'm just going to write 3 times x, and we can actually just put 3x, that's implied multiplication. So January's got x, February has 5 less than x, and March has got 3 times x. So by the end of March, he had at least, okay, so this is where inequality comes from, at least 75 cards. So at least means that's the minimum that he can have, but he can definitely have more. And at least means you can include that. So what we're going to do is we're going to say, all right, you are at least 75. That means that's the smallest you can have, so you can be greater than or equal to 75. Because that at least means it's greater than that, but it can also be 75, so greater than or equal. So how do I put all this together in an inequality? Well, what we have, or we've got 3 different chunks, right? Let's think of them as our terms. We've got our x, x minus 5, and 3x. So to begin with, what we can do, I'll create a spot for us up here, is we can just take these 3 terms and we can combine them, right? So I'm just going to put parentheses around each of them to separate them. So I've got my January is x, my February is x minus 5, and then my March is 3x. Now, I don't really need parentheses around them, but visually that just helps us. And all of that together is at least 75. So that's greater than or equal to 75. And we don't even necessarily need to figure out what x is. We need an inequality to represent that solution set. Now, this is technically correct. We have listed the terms for January, February, March. But if this were a star question, you wouldn't see it like this because we have several x's that are out there. So what we can do here is we can combine like terms. So how many just raw numbers do we have out there? We call them constants. Well, we've just got this minus 5. So that's the only one that's just standing on its own as a minus 5 plus 7 minus 8. Just what are just what we call constants. Those are numbers without any type of any type of x, y, whatever variable we're using. So we only have that minus 5. But how many x's do we have out there? Well, let's think. I've got an x here, and I have an x here. Then I have 3 x's here. So 3 x's. So I really, right, could think of it like this. I've got an x plus an x plus an x. That's 3 x's. So I've got 1, 2, 3 x's. So if I've got 1x, 2x, 3x, 4x, 5x, I could actually combine my x's into 5x's, and then my constant is minus 5 greater than or equal to 75.